My name is Theodor Malcotsis. I am a researcher and a company advisor at the Fraunhofer Institute for Industrial Engineering in Stuttgart. This is in South Germany. And it's my first time here in Tenerife. First of all, I would like to thank the committee for the invitation. I really like this place. And when I arrived yesterday, I think I really did a big mistake. I relied on technology. Because when I stepped out of the plane, the first thing I did is I switched on my smartphone. I rented the car, I went to the car, and then I wanted to start the GPS in order to get in the hotel. So I wasn't prepared, I didn't print anything. So the connection was there, the 3G was there, but the internet didn't work. So I was in the car, and so I really was upset, because I said, actually I had to prepare, I had to print everything on paper, and then I had to go somewhere and use technology. So when I get to the hotel, I thought, actually I didn't do any mistakes. So maybe we should really do reliable technologies. Maybe this is more important. So you always identify problems that have to be fixed. And problems are always connected with opportunities. And this is something that I really like. Today I would like to speak about the early identification and the assessment of technologies. I will give you a very brief introduction about Fraunhofer and our institute, the Fraunhofer Industrial Engineering. Then we'll have a look into the 3D printing technologies, very short. And then we'll focus on the approach, and I would like to share with you how we are doing together with companies, how we help companies to manage technologies, and which approach we're using. So we can discuss about later. The Fraunhofer Gesellschaft is an organization, a European organization that really combines basic research with applications. So we are not, in comparison to the Max Planck Institute, we're just not doing basic research. We focus on products, focus on applications. We combine business and research. So this is actually the value that we are offering outside our institute, and we are getting funded by about 1/3 by the government, and the rest we have to take care that we get projects and partnerships, and also public projects. We really use a huge network around the world to identify problems, and then to really find solutions that can be marketable. So we encourage spin-offs, of course, and we have a great example here by Boris. And we have about 22,000 staff, about 2 billion budget for research, and as you see, 66 institutes, and they are mainly in Germany, but we have independent research units outside the world, so around the world. Our institute is one of these 66, and we are focusing on the technology management topic. We are focusing on the human factors, and we are divided into several business areas. So corporate development, we have human resources management, we have engineering, we have IT, we have mobility and urban system engineering. By the way, this is quite new business area that we have really generated right now, a few months ago. And last but not least, technology innovation management, where I'm coming from, where we really try to identify which technologies, which topics affect the future of companies in a very systematic way, of course. And on the other hand, we try to build up a culture for innovation, because it's always with change management related. If you want to change the way people work in a company, you have to speak with the managing directors in order to help them build a strategy. And then if you have the strategy, you have to really think how to do it in the company, how you encourage people, and how you're able to follow processes that enable the innovation capability to get better and better. So let's have a very short look into the 3D additive manufacturing. One very important question for companies, but also for research institutes and other organizations, are which technologies should a company focus on to be successful in the future? So what's happening is there are a lot of disciplinaries that affect the company, affect the special technology. If you're moving into one technology area, you try to find solutions to improve out of one certain topic. So if you think of which functions do I need for this technology, then you identify a really huge variety of areas that can help you to do this output, to generate the output and to fulfill the function, but also to identify new opportunities for business. And this is what we're trying to do. So let's see the current 3D printing technologies. There are a lot of technologies that are around this topic. And actually this part is many technologies are interrelated. So we have laser melting, we have laser sintering, we have the stereolithography. That's actually older. The whole topic started in the 80s for making rapid prototyping. And we have wire extrusion, we have illuminated object modeling, where you can really build up 3D objects with paper, with slides, with illuminates. You can combine different materials to do it step by step, layer by layer, to build a product. So in the undefined future, you may think of building really buildings, to construct buildings with 3D technologies. This is something very future-oriented, but let's see the value of that. I mean, you have different materials that you can use for different technologies. This is the reason why you generate the technology. The physical attributes are different requirements for something. So if you have a look in the roadmap of 3D printing, you see that here we took a lot of time to research on new materials that can be used for 3D printing. So the second thing that is going along here into the roadmap is it's 3D printing of soft tissues. I mean, we have examples where in the medical branch, you are able to print artificial ears, for example. I mean, you can transform, you can use laser scanning, you can mold something, and then you can put biophysical materials like cells, like collagen, in order to build a part of the body. So, and this is, I mean, it sounds very crazy, but this is really happening. So, and this is always improved. This is improved. This is very important. So, technologies for production of large objects. Currently, I mean, there are examples where you can print a 200 kilograms object. But this is the maximum. That's all. So there are activities and projects and universities and companies that are all together to find the solutions. You have ultrasonic-based additive manufacturing, so putting materials together by ultrasonic and then giving back another machine, like a CNC machine, to finalize the product. And then here, of course, you see there are a lot of technologies that can be hybrid, they can be connected in an automatic way, right? Step by step with 3D technologies in the background, because that's not all. So this is something that shows that there are different areas, different competences that have to come together in order to find solutions for that, in order to create new business models. I mean, if you think of being at home, having a 3D printer, and you are able to print a very short tool for home, if you think something, I mean, someone have to sell the CAD data. So if you sell the CAD data, someone else actually sells the 3D printers, and someone else sells the material. So if you sell the service of building the platform, having the CAD data, and people can customize it at home, I mean, that's a new way of creating business and companies and money. Yes,
in fact, there is a website like Napster in the past that store models of
yes.
3D printing. You know? I don't remember the name, but
yes.
it's on the net. You can access it.
I mean, this is the way. I mean, there are ideas that are already realized, but the thing is, you need really the marketing. You need the facilities for people to use it in order to use this business model. Mm-hmm. Now, sometimes it's too early. So you have to really come together with different partners in order to realize a project. This is, for example, how Daimler in Stuttgart did. I mean, we have the electromobility. This is a big topic in Germany. This is ecological, everything that is combined there. So Daimler worked with the public transportation company organization. They worked with different other partners, and they built a platform where you can, put the direction where you want to go. Then you can. Then they tell you which opportunities you have in order to go from A to B. So, and by the way, they use they use their cars, for example, and this is one part. So you can use these smart cars with electro battery in order to go from A to B, and then from B you take a train and you go somewhere else. So actually they make money because the people use their cars. You can rent it for an hour or something, or 2 hours, or half an hour to go somewhere. So,
at this time, you can buy the train here in Tenerife in MediaMarkt. It's offered with 2,900 euros. I saw 2 weeks ago.
mm-hmm.
So at this time, this is euro. And remember that Lego, the toys manufacturer, introduced as a revolution that you can design your toy and you ask to Lego and they send you, yes, at this time, Lego must be worried about this new technology. There is no necessary to have Lego at home to provide to your boy, or even to you. What are you thinking about? My new toy for join at home. So this is going to change the model of business of traditional companies.
Okay.
What are the material costs presently
yes.
for a 200 kilogram?
I mean, this is a cost. I cannot tell you what are the costs depending on what you're doing. You can use metals. You can use ferrous alloys, non-ferrous alloys. You can use thermoplastics. You can use thermosets. You can use ceramics to build a 3D object. But there is a company called Stratasys that sells printers and said it's the maximum 200 kilograms. I didn't test it, we didn't test it, but I know if someone uses it because it's a good marketing, but it works. But you have to really make materials more cheap, of course, that they can be used everywhere. You don't have a mass production right now, so you cannot construct something in a factory with these materials, with these technologies, and you're not able to reach a high-speed sintering or high-speed laser melting or something. This is something that will come in the future, so that the costs of material for these technologies are becoming cheaper, and this is something that people should be aware of, that there is something coming up. Daimler is showing big interest in 3D printing, because they think of customizing cars in the future. So you have different parts where the customer can customize and say, I would like to have it in that form. So it's very expensive to build tools and machineries and so on to build this for special customers, and then you just keep the machines in the room and you create costs. So you have a 3D printing idea, and you do it however you want and for which customer you know.
There is a long tradition here in Canary Islands about tuning the cars. You know, in the north of the island, there is a big business about tuning the cars. Yes, you can see on MTV that program that tuning your car. But here in the north of the Tenerife, there is a crazy guy that spends a lot of money to change the fashion of the look of the cars and so. Okay, I would like to change the face of my mother-in-law.
You're kidding, but
No, I'm not kidding.
This is surgery, not printing.
This is really a case where 75% of a skull of a human has been generated, built with 3D printing, with cells and so on, and have been implanted. So it's really a big thing. Dental. Yes, for the teeth, you use it for many years. You can. There is a case where a part of the body after an accident has been built with titanium, and it was implanted in part of the face of someone. I mean, there are a lot of examples, and it's important to be aware of that. This is the point. But how? This is all great. It's nice to know it. It's a dirty job to do it. So. I just want to share how we are doing. We use something we call technology radar. We try, first of all, to identify specific technologies for specific requirements. So we have the different technologies. We bundle them into technology fields. We know what they can do, and then we then create different requirements and criteria that have to be met. This is something that has to be done, and then you have to evaluate if this technology field can meet these requirements that are important for the company, that are important for the customers, that are important for the machines, for the process, and so on. Let's take an example. There was a company that produces engine drive equipment for forestry. So, and the problem was, if they build these cubicles, this shouldn't oxidate when you use it in the forest, so you can water in it. So we have to see and look if there is a chemical element present on the surface that might bring a negative influence. How much of this element exists on the surface, on the 3D level, and then how is the concentration of a special material, chemical element on the surface. So let's say how deep it is, how deep it goes if you finalize the surface. So the step was, of course, first of all, define the objectives. Which technology needs the company? Which technologies are existing, and which technologies can be used right now or in the future? And then break down the technologies and functions. Collect data, of course, on electronic base, but also on primary research by interviews and putting different people together, having interviews, analyze the data, and then run the assessment. First of all, we define a requirement profile of technology. The presence of the chemical element on the surface. This is one term, but you can find solutions by saying, what is the amount of the element on the surface? What is the concentration of the element with an example? So which metals, which materials, which criteria have to be broken down, and you can do it in terms of workshops. So there's nothing that can be generated automatically. You have to first come together with the people that need that, and then discuss it, and then collect data. So there are a lot of search terms that have to be generated in these workshops in order to be able to search for a function in a different way. So you can use different materials that then avoid oxidation, and these are all connected with different approaches. So you have to create different bundles of research terms, and then to use data. Data, which data? I mean, you have the patents. I mean, we have 55 million patents. And each patent is structured in the same way. You have a problem, and you have a solution. That's always the same thing. You have databases of literature. You have technical databases where, by the way, these all are not always free. This is a problem. This is the hidden internet, we call it. Because you have to be a member. You have to have, the account. You have to pay money for use this. So this is, of course, a problem to do it by yourself. But there are a lot of information. There are a lot of people that of partnerships that can be used in order to reach that, and having all this access, as we do. And let's see an example. I mean, most of the people, what are you doing if you have a question? You put something in the Google, isn't it? So you just put detection of chemical elements in the Google, and then you are extremely fast, and then you search in 0.4 seconds. You have about 8 million entries. So this is actually a lot. So if you start reading, then it can be a long story. So I would like to use a metaphor. Well, what you actually do? You go to a library. By the way, this is our new library in Stuttgart. It's a lovely place. So, and then you have an idea, and you have different search terms that you have defined. And actually, you should do the same things. You go and you search the database, or you ask for it. Then you take the recommendations. You go to the bookshelf. You take out the books. You have a look in the abstract, and then you read the book. So actually, it's the same thing that we are doing, but not by going to the library, by collecting millions of documents, and we are using Luxit. Luxit is a text mining system that is very helpful, and in order to scan the different search terms that we have put, and we have a document overview with the different words that affect our objective, and then we build the interrelations of different topics in order to find out which functionalities can be fulfilled with other technologies. And so therefore, at the end, we have new insights. And the last step is to assess the promising technologies. So as I stated in the beginning, we have the technology fields on the one hand, And we have the different criteria of different solutions. For example, for this approach, does this approach meet these requirements? Does this approach is able to detect a chemical element in a 2D or in a 3D perspective? Yes or no, or a little bit. I mean, this is something to have an overview which technologies might affect my company in order to focus and really monitor this technology in the future, because it's not value if you do it for 1 year and then you let it, because it's always a further development. So, and again, this is not a joke. This is not something. This is not for fun. This is work. But if you do it in a systematic way, if you have the people that are doing it in a systematic way, then you have the possibility to identify these white spots, what you say, in order to further develop and then try to think about how can affect me and which business model can we derive out of it. So in this case, we found 100 technology that fitted. 24 were very narrow to this what we wanted, and then at the end there are just 3 that really were implemented. I mean, this is something. We say also, if you have 200 ideas, you are lucky to realize 1. So that's enough. So the second thing is, which new markets or business areas can we open up with the current technology portfolio or with the new technology? So we said which technologies can affect us, can do the same thing as the other, and how is the further development. But another thing is, if I have a new technology, maybe I can derive different applications, and to use it for different products, for our technology. Another example, maybe all of you know the organic light emitted diode. This is nothing else that kind of illuminate with polymer. And if you give power to that it's lighting. So you can use it for different things. So if you have the competence to develop these things, then you think, okay, where is my market? I mean, you can use it in the mobile phones. You can use it for generating this digital paper. You can do it. You can use it in different labels in the street. You can use it for walls, maybe for design. You can use it for TVs. You can use it for bags. You can use it for at homes in order to give light, and very nice light for the whole wall. If you replaced this tablets, and also the car. I mean, this is something that it's not realized yet, but people are working on that. So and someone that is able to develop these polymers might think which application are needed for these polymers. So, other attractive applications we can address with our actual technology portfolio, and which requirements do the relevant, attractive future applications have in my technology portfolio. So again, there are different things. On the one hand, by an example again, we have the inertial sensor. The inertial sensor can accelerate. It can measure the acceleration, so you can use it in the airbags. But also, if you break it down, you will find some sub-functions like speed detection. You can break it down again, and you can use distance measurement. I mean, this sensor uses all the 6 degrees of freedom, to detect the acceleration, the speed, the distance. So you see how many kind of applications can you derive out of it. And again, you have functions. You have the attributes for each function. So if you talk about OLED, you talk about light, how many looks it. it's a blue light, it's a red light, what kind of light you want, how much energy do you consume. And on the other hand, you have markets. What does the market need? So, and if you have the special requirements of the market, you have the technology and the requirements, and you have to match these things in order to derive new things, derive new projects, and then new products. And as a last step, and this is always, let's say, optional, because it is connected with the deepness of the technology. You can use patent search in order to identify these white spots. How do we do it? As I said, there is always a problem and a solution in the patent. We're using these millions of patents. We are defining the search term. We use the text mining system, and then we try to find out which patents are affected in this huge database. And after that, again, we come together with people. We have workshops in order to really find out which problems can be solved with different solutions. Because only for one problem, for a solution, you find a patent, and there is a patent. But maybe you find a solution for another problem, and there you say there is no patent actually. You can use it, and you can apply it for a patent, and then you can think about the business model. You don't have to produce it, but you have to think about how this patent, how this technology can be used. Something that is missing on the market. And then you assess it and find out what's the value for that before filing a patent. So a last example about this topic, turbines, for example. The turbines play a real big role in the energy and aviation market sector. So the challenge is that you have to minimize the fuel consumption. You generate energy by investing energy. So, and you have to minimize the emissions. So by the time the surface of the blades are getting weared, so the surface is not proper anymore. And what would you do? If you replace the turbine, that costs a lot of money. But if you stop the turbine and you have created a new technology, how you can fix it, maybe in a few hours, then the machine runs better, has better aerodynamics, so the fuel consumption is the same as the beginning, as the product was new. And then, so you have a better operating time, and you don't need to invest in a new machine. So this was the result out of the use of this white spot analysis with the patents, where I explained. And we found out that the laser melting technology can be used just for blades, and then we filed a patent on that. And the patent is very attractive for this business, actually, because this also builds up upon the 3D printing technology. You can put this material with the laser, and then you can build layer by layer the parts that needs to be fixed, and that's all. So thank you very much for your attention.